So Catalyst has enabled OApps to build and host two powerful marketplace extensions within 3 months. So OApps, is a boutique development firm which develops a lot of applications. The challenge that they were facing was that the data that was coming in from Zoho CRM and other third-party sales applications was siloed, which made it tedious for customers to collate and make sense of data. They had no proper mechanism to track service requests, and there was no communication track available to customers. So if there was a service request coming in, the entire part around the communication of that service request was something that was broken. Through Catalyst, what they essentially did was that they built and hosted an application called OSync, which essentially synced data between CRM, the third party sales applications, using the Catalyst serverless platform. Catalyst was also used for building the Java functions, hosting and running of a Twilio integration, which enabled them to pick up content from Zoho Desk, pick up the replies that were coming onto Zoho Desk, and sending it to the end users via the SMS and MMS integration that Twilio had to offer. All of this was completed within 3 months. The features that they used for this particular for these two applications were Catalyst circuits, web client hosting, functions, and data store. Clean Label, which is an e-commerce firm that operates within the sustainable space. They focus a lot on sustainable packaging. Were able to save about 30% in their operating expenses by digitizing a reverse logistics solution. So the problem was that Clean Label was keen on recycling the storage containers. So they used to, with their product, they used to send out big, large glass containers to their customers, and they were keen on recycling, and they wanted to know, if the customer that they were servicing or the person who had placed an order had their packaging or not, or essentially their jar or not. How were customers keeping track of the container that they had, and how could they optimize the container collection process? Because they offered the ability, or they offered the option to the user that if you already have a jar, you place an order from us, we will replace that jar, or we will take back that jar while we give you a new jar. But for the jar that you give back, we will give you some amount of money in terms of credits, which you can use in your subsequent order. How we helped them, or how Catalyst helped them, was Catalyst enabled them to track containers by company and customer by integration into a CRM. Gave the right input to ensure picking up any empty containers. So it flagged the right kind of orders, that this is an order where a return pickup of a container needs to be done, basis the data that was fed to it from CRM and from the customer. It also helped in building a web portal for the staff and customers to track. So the staff to track the container availability at a customer location, and for the customer to track the kind of money which was involved in the process. So if I have, say, a product which is for 100 rupees, and out of which 10 rupees are something that I'm supposed to get as credit in terms of the container which I can give back, the web app essentially allowed for the delivery partner to know if a pickup has to be made, and it allowed for the customer to understand that there is some money which I will get as credits, which I can use for my subsequent order upon pickup. It also helped in the delivery staff to verify the condition of the containers using an inbuilt image moderation feature. So the image moderation feature that is inbuilt inside of Catalyst is something that was used to recognize broken glass, to recognize any deformities in the glass jar, so that the delivery executive, or the pickup executive, could essentially click a photo and have it documented and have it validated as well in the backend. The kind of features that were used in this particular use case were file store, cron functions, image moderation, the email service, advanced IO, and data store. So, as Morpheus is saying, I mean, there are servers in serverless. So, while we may call it serverless, doesn't mean that there is no underlying server servers being used. There are servers being used, and we'll quickly see how. Catalyst in itself is a pro-code full-stack serverless platform that offers developers the reliability of Zoho's infrastructure. So Catalyst is based on Zoho's underlying cloud infrastructure. Zoho has delved into three types of products broadly. There have been no-code, which involve no coding essentially. There have been low code products that involve a little bit of coding for to offer customization. This product as Catalyst is a pro code full stack serverless platform, which essentially means that it gives the entire power of customization and app development to the developer with with the thought of enabling you to build custom applications to suit whatever use cases that you may be looking at. Before we get deep into serverless, let's just have a look at how deployment models have evolved over the years. As I was saying, that Catalyst is a pro code full stack serverless platform that offers developers the reliability of Zoho's infrastructure. So essentially, you're utilizing Zoho's cloud infrastructure to build custom applications without having, you know, to spend that mind space in managing servers, in managing patching, and in managing the entire gamut of infrastructure that you'd be building your tech stack on. So before we get into what serverless is, let's take a look at how deployment models have evolved over the years. So in the x-axis, you see decreasing stack implementation. In the y-axis, you see increasing focus on business logic. So essentially, what we are saying is, as time has progressed and as application development has progressed, we are constantly moving towards decreasing stack implementation, which essentially means that we want to focus more on code and not focus too much on the underlying enablers or enablement that goes into developing that entire tech stack. So we started off with bare metal, which was basically on-premise servers, which meant physically managing and configuring the servers, the environment where the code was supposed to be deployed on. Moved on to virtual machines, which essentially was resource optimized bare metal, but still we were living with idle times. So the point being that there were a lot of times when your infrastructure is not being used and you have a lot of idling happening. So there was no usage, but you're essentially paying for that infrastructure at that time. We moved on to containers, which essentially packaged the application code and all the dependencies into small little containers which could run on any underlying infrastructure. So this was a little further than the virtual machine concept, where we kind of optimized it, containerized it to make it localized between the same machine, and then add the flexibility of being able to run it on any underlying infrastructure. And then we come to serverless, which essentially meant abstracting from all underlying infrastructure. So which meant that you do not need to focus anything on things other than your application. So what your focus is on is purely on business logic. You're looking at the prime application, the prime part of your application, and you're not looking at the supporting elements that go behind it in terms of the stack implementation. Interesting to see how it evolved. Here we see how we moved from a complexity point from monolith to microservices to serverless. So serverless in terms of complexity is right at the top. So we moved from monoliths to microservices with the prime objective of handling more load. The microservices to serverless transition was aimed at reducing cost primarily. So if you look at it, monolithic architecture had various components that were interconnected with each other. So the orange blocks that you see over here are our code, and the gray part that you see in each of these bars is the wiring. So what meant at a monolith architecture was that you're spending a lot on code, everything is centralized, everything is interconnected, and points of failure are enough and plenty. So if one particular component was to go down within the entire infrastructure, that would have a cascading effect or a domino effect on other components availabilities, and that essentially meant that you're kind of risking the entire system by having a lot of interdependencies. Thereon, organizations moved to microservices, which meant breaking down every component into smaller parts to run separate processes. So in each, if there were to be a failure in one particular component, that would not necessarily impact another component which was running in parallel, because it was broken down into smaller parts. There are separate processes being running. Each microservice has its own logic and database. So essentially, we've decoupled the entire environment so to speak, in order to create while maintaining those interdependencies, to try and separate them from each other in order to uh, create the ability to handle more load. Moved on to serverless, which effectively meant that you can run any function without worrying about the infrastructure. So you see a lot more focus on code. There are servers, the software tools, backup and scaling, which are part of the platform. So you don't have to spend a lot of man hours in configuring servers, in patching servers, updating them, installing OS, and scaling them in case you preempt a lot of traffic coming onto your servers, or if you preempt a lot of load coming in. And all of these background activities, if I may call them, uh, now become the responsibility of the cloud service provider. So here you see that there is significantly more value that is being added to the product by the cloud service provider. So instead of giving you a virtual machine which exists somewhere in the world which they can access, this meant moving on to a more value added service where you're getting a server which is there somewhere, which is highly available, but you're also not having to do the associated tasks of making sure that the server has enough uptime, patching the server, putting in an OS, and doing the entire logging part. So to sum up this slide, microservices is a way to design an application, but serverless is a way to run it. So while a lot of people will, over the internet, you will find a lot of examples where people tend to go from serverless into microservices, and it kind of blurs the line. The interesting part is that you can run microservices on a server full environment, and you can run microservices on a serverless environment as well. So as I just summed up, microservices is the way to design an application, while serverless is more a way to run the application. So let's get into what serverless is now that we have a little bit of context. Serverless computing aims to abstract server management and low level infrastructure decisions away from developers. So, what we're saying is that applications are developed without having concerns for implementing, tweaking, or scaling a server. So, essentially, anything that goes into the territory of managing the server, about managing scale ups, of implementing that server, ensuring the uptime, all of that is something that is taken away from developers, and developers are enabled by serverless to focus more on their business logic and more on the application logic. Resource allocation and scale ups are managed by the cloud provider instead of the application architect. If you look at serverless, we can divide serverless broadly into two. There is function as a service, which essentially provides all the computational muscle on the go to carry out a function which is designed by the user. It requires a little more than the code itself, which the service can execute when triggered. So important points about function as a service are that it provides you computational muscle on the go. So essentially, whenever you need it, it's always available. You Whenever you need it at whatever I would say whatever kind of scale you need it at is something which will be made available, and it will require a little more than the code itself. So you need to focus on your logic and focus on the kind of connections that you build in terms of those particular functions talking to different components within your application, with the objective of making sure that all of these are executed when they are triggered. So why triggered is also important is that there has to be an event, or there has to be a particular instance in which this particular function is being triggered, which causes it to be serverless. So essentially we are saying that whenever there will be a call to this particular function, that's when it will kick in and come into use, run its particular life cycle in terms of whatever that application is, whatever this function is supposed to do, and then go back off. At the back end, what will happen is that you will essentially be charged for whatever time that you're utilizing this, or whatever utilization that you're creating it for. The second component of serverless is BaaS, which is BaaS, backend as a service, which gives you pre-written software for activities that take place on servers. So there'll be user authentication, there'll be database management, there'll be file management, there'll be remote updating, push notifications, and the likes. it also includes cloud storage and hosting. So everything that you do with backend, it provides you with a steady, stable, heavily available mobile backend, which takes care of all the other activities that you were supposed to do, or that you were expecting from a backend, and makes it readily available and at a pay per go model. Now that we have an understanding of what serverless is, let's look at why serverless, or essentially what are the advantages of going serverless. So, as one of the major things that we've looked at is essentially that you get to focus on code. Uh, all the underlying infrastructure activities have been abstracted to the cloud provider. The cloud provider is responsible for maintaining uptime, patching, logging, everything that we've been speaking of. So, which leaves a lot of time to your team and to your developers to focus more on their core code. Auto scalability. Given that you do not have to manage servers, and you do not have the limitation of a certain computational capacity or a certain backend capacity, uh, all of these requirements that may arise due to heavy usage of your application, or due to a lot of users coming and logging into your application, are something that comes as a part of serverless, and that comes within the auto scalability feature. There are no idle times. So in a lot of cases, you have applications that may be running for a certain few instances and may be running idle. So there may be a lot of idle times for which effectively you're paying money because you've taken that server for a particular load. In a lot of times, there will be cases when you see a lot of idle time in terms of, say, certain times of day, certain lean months that you may save during the entire usage cycle of your application. So serverless makes sure that you do not have any idle times, and the fact that you can again pay only for whatever your usage is. There is faster time to market because your average developer is spending more time on developing the application, or developing the core functionality of it, or developing the core business logic, and not spending a lot of time on ancillary activities like making sure the servers are up, that they're patched through, that if there's an OS update that's happening, and all of that. You pay only for execution. So anything that runs and there is a call for it, and whatever utilization you generate out of the platform, that is what you pay for. You do not have any fixed fee. You do not have any minimum guarantee or anything that you need to pay upfront as subscription charges. The serverless applications are highly available. There is multi-zone availabilities. There is a lot of fault tolerance built in, so you can rest assured that in terms of the applications that you build on serverless, they're highly available. And the last one being that serverless supports multiple languages, and it's generally considered polyglot. So you have multilingual support, so you're not tied down to any one particular language that your coders may be. So you don't need to look for people who are adept in one particular language when it comes to writing code. Multiple language support essentially means that people can code and can make microservices, or can make applications or smaller parts of applications within the serverless space with the language that they're comfortable with. Let's look at a few common use cases that exist within the serverless space. So we have a list of about 10 different use cases. We'll just quickly go through some examples of all of these. So scheduling batch jobs, especially when intense parallel computation or IO is required, which means that there could be a use case in which you are processing data for an omni-channel organization, where you are required to process a lot of data coming in, say, from online sales, from offline retailers, from your own direct to consumer website, to collate all of that, to build that into a particular database, because it's coming in different shapes and forms from everywhere. You do an ETL, you can then apply machine learning for say predictive analysis on this kind of a data set. So you collate it from coming from everywhere. You know that it's going to come at a particular frequency, so you probably don't need to run it throughout the month. You cut it into different lenses in terms of say sales by geography, sales by time of the day, sales by day of the week, and to try and figure out different types of predictive analysis that can be applied to such large data sets. The second part would be around change data capture or database updates. So a lot of database inputs could go. So you could read a particular database, have a certain transformation in terms of the kind of so if you're looking at one or two multiple complex tables, looking to read data from it, transform it into a certain way, and then post it further into, say, a data visualization platform like a Tableau is something that could be considered through this use case. The third part could be the third example is around processing multimedia tasks. A very good example of this could be that you're running an application in which users that are scrolling are looking at small little thumbnails of images or of products. You can tap and hold on a particular image to see it resize and blow up. So that's one use case that can be effectively solved through serverless. Handling inputs from IoT sensors. So in case you're looking to develop, you have a lot of IoT sensors in sensitive areas like server rooms, or in cases like neonatal ICUs, where you're constantly taking in inputs from the IoT sensor around temperature, humidity, and other atmospheric conditions, where you can trigger certain alarms basis the kind of inputs that come from IoT and the action. So, for example, if you put this up in a server room, if you have multiple IoT sensors in a server room, you sense the humidity going beyond a point, and you sense the temperature rising to a certain point. A smart input can be generated and pushed out as an output could be that you turn up the air conditioning. You have automatic doors that can open in case there is a fire detection, or you can send adequate number of alarms to different people. You could also integrate the entire serverless use case with, say, a communication platform like Twilio in this particular use case, and shoot out messages or emails to concerned user groups saying that there is some problem that we're facing in terms of the environment, in terms of the temperature and humidity status in the server room. Mobile backends can be built. So within the mobile backends, if you were to look at the use case of, say, a reverse pickup that happens. So if you order through an app, if you were to order, say, clothes from an app, and the reverse logistics partner is, and you don't like it, and you're wanting to return that. In that case, what you could also do is you could program the application in a way that the person who's coming to pick up can easily scan a barcode and create a return item in progress, which links back to the main backend. So that's one thing that can be used. Chatbots at scale can be made out of serverless. Then HTTP, REST APIs, and web apps are something that you can build. So something within the REST APIs concept, we're looking at something like a parcel tracking system. So if you've ordered something from anybody, there will be a tracking code that you will get, or a consignment number that you can get. So the entire parcel tracking system that exists on, say, a logistics provider's website is something that can be made through serverless. So essentially, you go in and put in your parcel code, and it returns you the data around where it has reached, or when is the delivery expected, or who is it with. Continuous integration pipelines are possible on serverless. Stream processing at rate with the likes of all OTT platforms, they can utilize on serverless. And then microservice or orchestration to support business logic, which essentially means you can automate a registrations process. You can tag certain banking transactions through this particular feature, or you could, say, configure, say, a payment gateway. So if a particular payment is failing, you can create that automated logic, or that orchestration, which says that if the payment fails once via a certain mechanism, you need to retry it for a certain number of instances, and then come back and say that the payment isn't going through. Do you want to change your mode of payment, and all of that? So these were some of the common use cases of serverless. Catalyst is a product of many firsts. it is the first serverless product completely built on Indian soil. So it is an entirely Indian product. It is also the first Indian infrastructure provider which has come out with a disruptive pay-per-use model. So let's just quickly look at how Catalyst empowers developers. In terms of the types of service, we provide you both functions as a service and backend as a service. We offer you the ability to build microservices, to have a managed data store, and even to do web client hosting. The types of apps we cater to do both kinds of mobile apps, be it Android or iOS. We also have the capability of web apps and microservices. And quickly on why Catalyst, we'll be going into it towards the end as well. We want developers to focus on apps and not ops. We offer you the ability to scale rapidly, and essentially the pay-per-use model enables you to do all of this in a very cost-effective manner. So this is what the broad Catalyst architecture looks like. What you will be able to build through Catalyst will be web apps, mobile apps, and microservices. You will build these basis the backend as a service and functions as a service bases that we have, which essentially contain but are not limited to data store, file store, and cache within backend as a service, event driven, advanced IO, basic IO, and cron functions between functions as a service, and the different components that we've added within Catalyst in order to make the development process faster. So we have all of these modules and more that have been built within Catalyst as components which you can use as a plug and play module. What is interesting is that similar, in other situations where you may use all of these functionalities available at other platforms, there are instances in which you are expected to pay an upfront subscription to add that particular feature to your stack. That's something that is not there in Catalyst. Essentially, whatever you pay for, there will be a different credits association to the kind of usage that you can generate out of all of these, and you don't have to pay anything upfront. So all of these are plug and play. I'll just quickly walk you through. There is user authentication modules, there is the email integration, there is the entire Zia suite, which is the AI ML offering that we have, schedulers, circuits, logging, notification, and a whole list of other components that we will also go through in the upcoming sessions. Within Catalyst, we have three environments. We have the local machine, we have a development sandbox, and production. So again, the local machine is aimed towards the developer. The development sandbox is for use of the entire team, and the production is when your code goes out towards the entire world. So the local machine and development sandbox are entirely free. When I say entirely free, anything that you do on the sandbox is not chargeable. There is no credit card sign up that is required. You are not required to pay anything upfront, put any membership or anything of that sort. When you go into production is essentially when you start getting charged. So if you have heavily tested your application on your local machine and deployed it on the sandbox to see if everything is working, that kind of ensures you that you do not need to spend any money in real world test use cases that may happen on production. So you pay nothing till you deploy the project on production. You get a full featured sandbox. So all of the features that exist in the production world are something that you will get access to within the sandbox. And within production, the interesting part is that you get up to 125 million free invocations for the first year. So a lot of what your development within the first year is going to be can be utilized by the free credits that are on offer. Pricing calculator now. In order to access that, you just need to go to catalyst.zoho.com and look at the ribbon up top and click on the pricing section. This will lead you to the pricing page. What I've done is I'm going to walk you through our pricing calculator. So through this calculator, you can try and simulate the kind of usage that you expect from your application and toggle the number of calls that you're going to be making for functions, for circuits, for data store, file store, cache, intelligence by Zia, I mean, just taking up that question. So if you were to say use the OCR application for 5,000 calls, and if you would, I'm just putting in certain notional values to show how the entire credit system will be calculated after you toggle with different number of function calls or different number of invocations that you're going to be doing. And towards the end, it then shows you the total number of credits that will be billed to you monthly and the amount that you would be required to pay monthly. Now, one more example that will help you understand is that this particular use case that exists on the website is something that I would recommend, or I would urge everybody to go to this particular section to try and understand how the pricing would work, play around with the pricing calculator to see how it would work. This particular use case is for an e-commerce website that sells chocolates and candies. They know that they're going to be seeing peak traffic during Halloween, and they're going to have a low traffic month in September. So this illustration shows that within the September to October, what is happening is that while your usage is also spiking, your the Catalyst pricing is able to understand if you're doing a light usage or heavy usage, and basis your usage. If you are going into heavy usage, there will be a fixed fee that will be applied, but your usage per credit fee will significantly go down. So over here you see it's going down uh, by a tenth. So that automatically toggles to make sure that so so over here, if you were to do light usage, your usage per credit would be as much, with a fixed fee of 0 rupees. With the same number of total credits are now consumed, you would come at two different price points which you could get. But the monthly billing that will happen to you in this use case would be 390 instead of the 639 for a heavy usage. So Catalyst will, if we look at the illustration for October, Catalyst will automatically calculate if you are moving into heavy usage and try and evaluate what the cost is coming as per the light usage and heavy usage pricing, and then bill you the one that is lower. So even though you do try to evaluate or estimate the kind of cost that you can get through the pricing calculator, the dynamic input that comes with heavy and light usage is optimized in a way to make sure that your costs go lower. We'll now move towards a brief walkthrough about the platform. So you go on to catalyst.zoho.com. It will ask you to sign up. I mean, I'm already signed up from the account. So you click on the Access Zoho Catalyst and it will load up the platform. I have a test project that is made from a backend as a service perspective. So I'll just give you a quick walkthrough. As we had spoken during the presentation, there are 125 million free invocations that you get as part of sign up. That roughly translates to about $250 in credits, which is something that is prominently available. I mean, you can don't need to worry about that. On the left, you will see all the components. I mean, from the home button, you will be able to see different projects that you've been created. You will see the develop, compute, amplify, discover, and host and manage sections on the left ribbon. If you scroll down, you will see a detailed instruction on how to install the CLI. There is help for CLI command, which is there. There is also a detailed video that we have that will give you a view of, or that will give you a step by step directions as to installing the CLI. If you scroll slightly down below under the fold, here is where you will see all the resources that are available. So you have all the resources available in one place, and you have specific URLs for the SDK and API documentation and the component help. So I'll just take you through the resources page. So getting started will get you up to speed about setting up the CLI and how to use the platform. The component help will delve deeper into different types of components, right from authentication to data store, file store, cache, cron, ZCQL. Within the compute, the functions, the circuits. Within the amplify part, the search, email, push notifications, the event listeners, the GitHub integration. It will give you access to the Zia services and the entire AI ML documentation that exists, and the part around web client hosting, domain mapping, and application alerts or notifications. The SDK API documentation and the component help are essentially subsets of what we've seen. They will take you one level deeper. So this will take you directly into the SDK documentation, and the component help will take you into the components that we just saw. Moving back, if we are to look at it from a backend as a service, the data store table, you'll get the ability to create a new table over here. You have a schema view, you have scopes and permissions that you can modify, and you have a data view as well to look at the different entries that have been made in this particular table. The ZCQL console will allow you to run SQL queries over here, which can output data which is there in the table that we just spoke of. This particular table, and this particular feature is I'll go back to a use case to make it slightly more relatable. The use case in question being that if you are to do a data transformation activity, so for example, if you have data coming in from 5 different sources, where while you have one singular SKU, but for everybody the SKU ID or the product code is different. Let's say we're talking about a grocery retailer who's selling or a grocery brand who's selling their products across multiple different channels, and all of these individual channels have different names for the same product. So all of that unified mapping could be created within the data store table, and data could be read coming in from different sources, transformed into one particular SKU code which the organization understands, and then transformed or manipulated further in terms of any predictive analysis that you may want to run, or if you just want to output it into say a dashboarding solution, or if you want to feed it into something like say a Tableau or a data visualization BI dashboard. The file store section is again, here you have the ability to give specific file access or specific folder access to different types of people. I've created a sample folder over here. On different folders you can toggle on permissions basis different user roles. You can allow people the ability to download, upload, or delete these files and folders. So one particular use case that is being one particular application that is using this use case and this functionality is around an organization that or a application that is being developed for different reports to be made accessible to different types of users. So there will be different user groups. So assume that within a hospital there are different departments. There is a pediatrics department, there is the orthopedics department. So basis the different user profiles that they will be creating, they want to create such central repositories which are accessible to only specific types of people. So that is one use case that is currently under development for this particular part. That brings us to the end of today's session.